righty. I guess it's 2 o'clock, so I'll begin. Welcome everyone to our Engineering Shop Talk here at TRC Electronics. This is a webinar, but it's also a different way of presenting different solutions that we've had with modular power supplies. So today we're going to be joined by Tom Denny and Nicholas DePaulis. These two guys have been working with modular power for almost 4 years now, and we've solved hundreds of different problems with different clients and also different industries using modular power supplies. And we're going to share some of those experiences with you today. Let's go through the agenda real quick, and this way everybody knows like what's being covered. So we'll touch on the complexity of modern equipment and also define, for those of you that may not be familiar with modular power supplies, what they are. We'll share with you the common applications and also the different features that a modular power supply can actually offer to help get it designed into a piece of equipment. We're also going to share with you our toolbox at TRC. These are the different modular supplies and partners that we have, where we can specifically configure them here in-house in Pennsylvania, be able to deliver them in a quick time frame. We'll go over some cost and time advantages, and also share with you how we support not only selecting the product, but also delivering to the client and ensuring that it's integrated with their solution. Before we go and move on, we will have a Q&A session, but you're more than welcome to chat something if you do have a question, and if we can, we'll answer it right on the spot. With that, let's begin, and let's talk about some of the modern architectures. I'm going to let Tommy explain some of the things here that come up when we look at different configurations for the designs that we're involved in.
Thanks, Mike. Yeah, just to touch a little bit on, the way modern architecture can be so complex. I mean, there's often multiple systems within one larger system. Here, we have the example of a robotic arm, and I pointed out a couple different voltages that would be used within this robotic arm. We have high power servos there at 48 volts DC. Servers are often at different voltages, but a lot of times these new high power ones are at 48 volts, higher voltage. HMI display at 24 volts DC. It's pretty standard. A lot of times your system voltage will be 24 volts. I show here control logic at 5 volts. Pretty standard for your control logic, 5 or 3.3. You can see the touch sensor I have at 3.3 volts up top there. And then a cooling fan at 12 volts is pretty common. Sometimes that's done with an auxiliary, or sometimes, it can be a higher power cooling fan, needs more power. And this is, of course, just an example. I mean, or a few examples. You can have all sorts of other voltages. A lot of times you'll have op amps in here that they're plus and minus 12, plus and minus 15. But all sorts of different systems require different voltage rails internally.
And some of the folks that join may be saying, well, some of these are handled with DC to DC converters, and that's true that some of these applications, some of these functions could go to DC to DC, but really when it comes down to when you want to deliver a specific voltage to a specific function, modular power supply is going to be able to deliver that voltage right away, even at, say, at the prototype level, which later on you may opt to go DC to DC, but at least at the prototype level, you can get something working fast.
Also allows you to keep things isolated. When you're doing DC to DCs, you've got everything run off that same system voltage. Here, you can have things a little more isolated.
Yeah, exactly. All right, so let's move on. Let's let's briefly discuss what is a modular power supply. Nick, walk us through some of this right here.
Sure, absolutely. I'd love to. So essentially the key elements that make up a modular power supply and how you can differentiate that from, let's say, a multi-output power supply is that they have a single input source and there's multiple outputs within a single package. Now, the important part here is that those outputs are both isolated and adjustable. This is the key difference between a modular power supply and our more conventional multi-output PSUs. There might be some variation on one or several of the output channels on a conventional multi-output. With a modular, every single one is adjustable and isolated. And with that, you get the capability to have wide adjustment ranges for those output modules, which is very useful to be applied to many of your different applications.
Yeah, and before we move on, one of the things we experience here is not only is it not only can we get the wide adjustability, but sometimes we get these requests for voltages that are a little bit higher than a standard output, and they only need one output. With these modular supplies, we can actually do that with a combination of the different modules that we have in there.
Also, if it's kind of a strange voltage, like 17 volts, not many power supplies will hit 17 volts, but the wide adjustability of these modulars allows you to get a single
Yeah,
output of
sometimes
17
it's pretty
volts.
funny the type of voltages we get. We're like, how did they get, where are they coming up with that? But really, what it comes down to is some of them are using higher voltages to get to a load and they're not doing remote sense. And that's where you may
Or
have some of those applications. So let's move on to some of the common applications that we'll talk about here. And
Sure.
I guess I'll start off with gaming systems because this is something that actually has come up personally a couple of times with a couple of clients recently. And one of them is, if you're looking at a gaming system, you'll notice that there are many different functions in there. And we have many clients who look at, well, the easy and most economical way is just put 4 or 5 power supplies that are low cost into the game, and that would solve all the different functions. But when you do that, what we don't notice sometimes is that UL becomes an issue, especially if you're putting 4 or 5 different types of supplies and they all have a leakage current. Well, they add up. And when you're done with adding up all those leakage currents, you may run into a UL issue in terms of meeting a minimum leakage requirement. Not only that, but you also have some mechanical issues because every single one of those have to be mounted and you have multiple ACs. So with a single AC input in a modular unit, you can actually eliminate all of that and actually save cost. And that's the cost that's hidden that you don't see when we're going with, let's say, the more common approach of multiple outputs. So that's one aspect. And I believe Nick and Tom, you've got some others here as well that you want to share.
Yeah, so I'll start off first. Essentially, one that's not shown up here, but also is very prevalent in the modular space, is point of sale machines or POS machines. Those I've seen an uptick in actually leveraging modulars for them due to the fact that there are so many different loads within those machines themselves that need to have very specific voltages and they all need to be isolated from each other. Specifically, ones that I've supported had, the bill scanner, you had the card readers, you have the screen, you have the scale that actually measures the weight. All those different types of loads need their own isolated output. And a lot of these machines, if you try to do that with separate power supplies, you're going to run into leakage current issues where you're not going to be meeting the industry requirement to be within a certain threshold. So modulars are very effective because you can put one in there and it's going to have below that leakage more often than not to prevent you from running into that type of agency requirement later on. And then you have to do a whole redesign for your system.
agency requirement or safety requirement too, right?
Exactly.
If we're looking at also on the lab industrial equipment, how many times we get requests, and you guys have seen this, right? Where I need to ramp the voltage within a specific range. And it may not always be a zero up range, but they do need to dynamically change the voltage from one level to another. And some of the modulars that we offer, and we'll get into the features later, but some of these modulars can actually do that, where you can actually change the voltage on the fly during the function of that ATE or automatic test equipment that you're trying to run. All right, so I guess with that, let's get into some of the features here that we just talked about.
Yeah, so a few features that I want to highlight. So the low leakage, you just heard Mike and Nick both talking about that. When you put in multiple power supplies, right, in a system, really what you're doing is you're putting multiple capacitances between your input and ground in parallel. So as you do that, your capacitance starts adding up, you're increasing your leakage. Whereas with the modular, you have a single input. You have one input there and then all your multiple outputs. So that really reduces your leakage issues. Series and parallel connections are a great feature of modulars. It makes it super easy to get either higher voltages or higher power. Uh, all of our modulars have built-in current sharing, which is super nice. Kind of simplifies that problem in a system. Programmable voltages and current on many models, as you just heard Mike talking about, like in the ATE space, the test equipment, a lot of times you need to be able to program voltages on the fly or program your current limit. So I think I think all of our power supplies actually allow for some programming there. Um, PM bus communication and other types of communication on certain models is a nice feature to have. And then we've got all these other little features here at the bottom. I mentioned DCOK. You know, if you need, have some LEDs you need to light up to let your system know that it's running as expected. Remote sense if you need a specific voltage right at your load. Auxiliary out if you have a small fan or some control circuitry that needs controlling. All of these are
And
pretty standard.
it's interesting, we when we see the spec sheet, we look at all these things. Let's talk about some of the value they bring in. First, the PM bus communication. Nick, we
Mhm.
just recently have a client that has multiple sites, I mean, thousands of sites.
Oh yeah,
And share with us, like, what are they trying to do and why is PM bus absolutely necessary here?
absolutely. So essentially, the client had a need to be able to pull various information from the power supply about its environment, what it's actually doing, remotely. So they have this system set up that they can access it through a network, and the wireless interface that they had only communicates via PM bus, and they needed this power supply, whatever the power supply ended up being, to have PM bus communication offered as part of the standard package. Now, the specific data they wanted to know what the ambient temperature was. They need to know what the fan status was, what was the output current at the time, what was the voltage, and what was the status of, let's say, outputs 2 and 3 versus 1. They needed to have all this information available to them, and having PM bus communication as a standard offering in a modular power supply is something that has been proven to be extremely valuable in many of our applications, not just the one that we just talked about.
All right, so let's move on to the portfolio. Now, as I mentioned before, this is our toolbox. These are the products that we have, the partners that we have, where we can actually configure, provided we have all the modules in stock, which in many cases we do, we can configure these different models. The first, but what I'd like to do here is just present to you, like, how do we attack the market or the application based on these different product lines? The first is Delta, and we leverage Delta for anything that's in the 2 to 3,000 watt range, because they offer modular supplies. They actually provide that type of power, and and they're very small too. If you look at their 3,000 watt package, it's 7 by 10 by 1.63. Now, albeit that's going to be on the higher input voltage, because at 3,000 watts it just makes practical sense to go to 220. But we have those abilities. And they also have ITE and medical in one front end chassis, as well as reversed fans, which in that case we'll have to order the specific chassis for that. The next one is Meanwell. And Meanwell's NMP series is actually the second generation product that they've launched a few years ago. And this is also an IT and medical all in one in chassis. And that, again, that provides us with the ability to have chassis on hand, not have to worry about whether one's IT or medical. Both Delta and Meanwell offer semi F47, which means that if we're in a semiconductor application, this is going to be a very critical requirement to ride through those brownout conditions that could damage semiconductor wafer production. And then the Meanwell is also field configurable, although we don't get a lot of requests. But if, let's say, somebody's working a prototype and they have to change out a module, we can send them a module and they can make the change and continue working their application. And they're also TAA compliant, which, as many of us know right now, if you're dealing with a government situation where they want to have that TAA compliance, the NMP is a perfect option for that. Next is Vox Power. They're well known for very small footprints. So they have a 3 by 5 in a 600 watt which is still one of the industry standards in terms of the amount of density, as well as a 1200 watt, which is 6x6 footprint. Vox has recently also launched a convection cooled option, which is 600 watts. This is also configurable here at TRC, and all of their solutions are field configurable as well. Their 1200 watt is medically has a medical version, and you'll see shortly they'll be launching an I2C communication feature, which again gives us that extra capability of programming units on the fly as we need to. And then finally, Inetto's been a field-proven modular for us. We've actually been configuring them since 2010. They also offer a very small footprint, 3x5, 6x6. They do have some capability of doing class number 2 options at 600 watts, something that you should inquire, and we can give you more detail on that. And they'll soon be expanding the power for that specific product line. I think, Tom, did they say somewhere around 700 watts and some peak power there?
Yeah, 700 watt in that 3x5 package.
Yeah, so stay tuned for that. And if that's something that you require, certainly come to us and we can give you more detail on that. All right, let's move on to the certifications.
And just to answer Harry's question there in the
Yeah.
chat, so field configurable, that actually means that you can add modules in the field without having to recertify, which is nice.
That's right. And also, if you have to change a voltage, as long as the module that you're adding has that voltage range, you can actually even make the change via potentiometer to change the output voltage.
Correct. Yeah. So yeah, if you're doing prototypes, and you need to make a change, it's very, very convenient for that.
Mm-hmm.
One of the big cost advantages here, actually, right related to that, is the certifications that you get with modular. Basically, you're getting a customizable product with the certifications already included. We've got medical certifications on some, industrial certifications on some, and some with both UL and international certifications. Imagine getting a prototype that's already agency approved without having to go through that entire process, which can be expensive and timely. Also, our production here is certified. We have UL certification, CSA certification for certain models, and also we're an ISO 9001 registered and certified company. So you're getting quality there.
Mm-hmm. So let's and a lot of times what comes up, if you go to the next slide, it's about time to market. And this, to me, this is I've lived this for over 30 years in the power supply industry. And I've dealt with working with clients that needed a customized solution where it took weeks. And if you think about the amount of phone calls and time in order to go through a project for a custom power supply that's being integrated into another piece of equipment, and now you have dedicated engineers on the design team worried just about the power supply. We're looking at custom solutions that take anywhere from 6 to 12 months. You want to look at NRE, 125,000 is typical NRE investment for a power supply, especially if it's got to be ground up. Yeah, if you're dealing with a supplier that might have something already in place, now it's more of a repackaging and then recertification, but the NRE is there. Then there are prototypes. They have to be developed. They're going to take several weeks to develop, and then you have to prove that out into the system. Now you go to safety. This is where you could get handcuffed. You're looking at 4 to 12 weeks, and that's if everything goes right and they don't find any issues along the way, which now requires a redesign and requires you to have more time spent, and that program goes out. Then pre-production and tooling. By the time you're done, you're looking at almost $200,000 of investment. You don't have a product to market. You're 44 weeks in, and it better be right. Now, in terms of is a custom solution the right solution for some applications? Absolutely. If you're getting into the thousands of pieces and you've locked it in, a custom solution is the way to go. But in the meantime, with products changing every 2 to 3 years, if you were able to just put a modular in there, spend the extra money because a modular may cost more initially, and then run it through the program, you'll be able to actually have a product to market much faster, decide what needs to be done, make a change on the fly as you need to be done. And then if that product is sustained and you know that you're selling, then you could look at a custom. So there's obviously going to be risk assessments, but I guarantee you that if you go into a modular application and you actually design it in, you'll be able to find out much more about how that product, your end product, is going to turn out. And your engineers are going to spend time working on the end product, not on the power supply one specific component. So that's kind of my experience over the many years as to it's almost a no-brainer. It's like just do it, get it designed in, and then figure it out later if you have the right voltages and currents.
So I'll take the slide here on the integration support side. So
I guess you would because your picture's on it, right?
yeah, that's me. Someone snuck up on me and got that one. So essentially the side we've already covered, the modular power supplies, we've explained why they're effective, why you should use them. Now, here's what you get when you work with TRC. So we support you basically from onset on. We give you live engineering support from the TRC application engineer team that just on this call here. And every unit that we produce in our lab is individually quality checked by the engineering team. So once the technicians assemble everything, we go through and make sure everything is as it should be. We do also offer additional modifications since we are the authorized repair centers. So we can do special labeling. We can even do circuit level changes depending on what that actually is. We have done that in the past for some clients. And as Mike mentioned earlier, if we do have the components, chassis, everything available to us, we can rush a prototype to you as soon as next day.
Yeah, not to mention you get white glove service too.
Yeah, absolutely.
All right. And before we get into the Q&A, let's talk about some key takeaways here. Guys, if anything from this short discussion today, we could tell you these are our experiences in engineering. This is what we face multiple times a week. And the first is that this is an excellent option for multiple voltage systems. We must configure 5 to 10 different types of configurations a week that come in where we're helping clients or either select the product or configure the product. The configurability of a custom without the cost of development and certification. Think about you need to turn your piece of equipment on today. And before, what used to happen is you'd have a bunch of lab supplies doing this. Here you have a bona fide certified product that can actually do it, and you can go to market with it. And then in terms of leakage current, these are some of the hidden things. We don't really see this too much until we get into the safety aspects of it. And we've had clients with this situation at the 11th hour where they're trying to launch a product and they're running into an application issue with multiple power supplies. So, and the other thing that's hidden is the hidden costs of the mechanical aspects. You have to mount all these other power supplies in a system. Well, you might have the space, but all of those require brackets, screws, mechanical drawings, cabling, all of that has to be figured in, and there's a cost associated with that. And then lastly, our support. We get involved we become part of your engineering team when we're designing any of our products, but modular becomes more complex because you have all these different types of voltages that you have to address and all these different functions. And we're here to support that because we have the experience with other products and other designs in the industry, and we're here to help. So with that, Tom, I guess you had something about modularity?
This was just a fun little quote I found about modularity by Bent Fluberg, that modularity is a clunky word for the elegant idea of big things made from small things. And that's basically what we're doing here. We've got our small modules and we turn it into a nice big power supply for a big system.
We have a question from Christian Bell. Do you find the modularity hurts power efficiency, and how do you manage those impacts? So I'll start with, as far as efficiency is concerned, most of our modular supplies that we have today, due to their size, due to our already over 91% efficient, Efficiency, but this is a loaded question because it also depends on how the system is being configured. So one of the things that I would say, and guys, you could step in on this, is when when you have a modular supply, but then you have long runs going from the supply to the actual system, that's where you could run into some efficiency issues. But again, it comes up from time to time
Yeah, and
as
I would say
possible.
yeah, and I would say in general, modulators are great with efficiency because you really, I mean, you're turning it up to a high DC voltage internally, and then converting it back down, which ends up being pretty efficient as far as that package goes.
Right, and then there's another question about, well, thank you for, Hari, thank you for the compliment. Do you have any medical power supplies that have AC to DC and PoE injector both integrated so we can use the DC output for the PoE injector output to the devices? And that's interesting. Well, off the shelf we do not, but we do have power injectors that are DC input. They may not be readily on our website, but we do have DC input power injectors that can provide that feature.
And also plenty of power supplies that we recommend for PoE applications, right?
Which is another point that some of the modulars we offer have output to chassis at 1500 volts RMS, which is important to meet the PoE requirements. So if you're powering a DC input, that would be one.
Goes
We
right
have
into the
another
next
one
question. Yeah.
here. Go ahead,
No, I
Tom.
was gonna say that goes right into the next question there. And it is
Yeah.
different with different modulars, but we have some that are as high as 1500 volts DC, like Mike said, which works great for the PoE applications, but it is different for different modulars.
Yeah, so the modules are all isolated from each other, and the isolation barrier is going to be output to ground at this point. So if you look at the output to ground variation, that's going to be I'm thinking out loud here. That's going to be the isolation from one modular to output to another, I would imagine.
Yes, that's correct.
Yeah, unless you ground one of the outputs to chassis, then that might change for that one specific output. But that's the other point, guys. It's like you might want to just common one to chassis. You don't sacrifice the other three floating outputs. All right. Well, thank you all for joining. I